Today's lesson, 6.6a, identifying geometric sequences. So as you can see here on the board, we've studied exponential growth or decay, and this is basically the same thing as that. So let's take a look at this core concept. Let's read through it. So in a geometric sequence, the ratio between each pair of consecutive terms is the same. And this ratio is called the common ratio. Every term that you generate in a sequence is found through the process of multiplication. So if you compare this to arithmetic sequences have a common difference. So you either add or subtract the same amount to move from one term to another. These have what's called a common ratio of multiplication. Let's get into some of these. So what do you think about these sequences? Are these arithmetic, geometric, or maybe there's neither pattern? Let's take a look. So for part A and part B, what do you think? I'm thinking in part A that if I look at these numbers, well, let's go this route. Let's take a pair of numbers. And let's see what we get when we subtract those numbers. So I'm going to go ahead and do that. I'm going to do 60 minus 120. Remember, always do it in reverse order. 60 minus 120. And what do I get? I get negative 60. Now, is that the pattern that we see in this case? Are we decreasing by 60 each time? Here you are. There you're not. There you're not. Is that subtracting by 60? The answer to that is no. So that one's not arithmetic. Is it geometric? Maybe. So how do we determine if it's geometric? Well, what we're going to do is almost the same process. I'm going to take those two numbers and I'm going to divide them in reverse order instead. So 60 divided by 120. Now that gives me 0.5. So the question is, am I multiplying by 0.5 in this case? Well, I'm going to go ahead and test that in my calculator to see if that's true or not. So you remember how to do this? Okay, I'm going to my calculator. I'm going to put in the first term of the sequence, enter it. I'm going to multiply it by 0.5. And I'm going to see if I get all the terms of the sequence. Well, there's 60. Will I get 30? Will I get 15? I do. So this is geometric because the terms have been reproducing themselves one after another through the process of multiplication. Let's go to part B. All right, what do you think about part B? Well, once again, maybe we should just look at a pair of numbers and see if we can determine what's going on. So 6 minus 2 would be 3, right? Is this sequence, I'm sorry, 6 minus 2 is 4. Does this sequence generate itself by adding 4? I don't think so. So it's not arithmetic. Let's try something else. How about we try 6 divided by 2? Isn't 6 divided by 2 3? It is. So is this a process of multiplying by 3? That won't work either, will it? Nope. So it's not geometric. So what we're going to say is that this happens to be neither. It's just something else. All right, let's try the same thing. You go ahead and try it yourself. All right, so I'm going to look at the first two numbers. And what I'm going to do is I'm going to subtract them. 1 minus 5. That would be -4. So the question is, do these numbers go down by subtracting 4 every time? 5 minus 4 is 1. 1 minus 4 is -3. Yes. This is arithmetic. It is. Let's go down to number 2. Consider a pair of numbers. Maybe try to subtract those. 128 minus 1024. Try that again. All right, struggling there. 128 minus 1024. That's subtracting 896. Does that work? No. That is not arithmetic. Can you think of something else that might work? Well, how about we take those pair of numbers and we divide them instead? See if it's geometric. 128 divided by 1024. I'm getting the number 0.125. So I'm wondering if we multiply by 0.125, does that work? Well, let's try it. Let's bring up our sequence of numbers. I'll move my calculator to the other side and try this out. Okay, so let's put in 1024, press equals. Let's put in the sequence, times 0.125. Let's see if we start getting the numbers from the sequence. Yeah, there's 128. There's 16. There's 2. Okay, I'm going to say this is yes. This is geometric. Okay? Let's go down to number 3. What do you think about for that? All right, number 3. Look at those numbers. Let's start with a pair of numbers and use those to test. 6 minus 2 would be 4, right? Do we add by 4 each time? 6 is 4 to no. That did not work. It's not arithmetic. Is it geometric? Well, I think we can do this in our head. 6 divided by 2 would be 3. Do you multiply by 3 to get each value? No, it's not geometric. You could try to prove it to yourself, but that's not going to work. So what we do is we classify this as neither. Get the idea? Okay. Can we write the next 3 terms of these geometric sequences? So we are being told that these are geometric. So what we need to do is we need to find the common ratio in these. And we're going to do it like we just did. Let's go ahead and take the first 2 numbers, and I want you to divide them in reverse order. 6 divided by 3 is 2. So the common ratio which we can just call R, is 2, because that's 6 divided by 3. So if I go to my calculator I should be able to get the next three terms. Let's go ahead and try this. All right, here we go. So I'm going to put my first term in. I'm going to set the sequence by multiplying by 2. And I should start to see all these numbers from the sequence. There's 6. There's 12. There's 24. I need the next three. So 48, 96, and 192. 48, 96, 192. 48, 96, 192. Let's try another one. Let's try part B. Okay, so in this case, take a pair of numbers. Maybe it really doesn't matter which pair you use. And what I want you to do is divide those in reverse order. And let's see what we get. So let me bring up my calculator. Let's move it over here now. Okay, so let's take negative 16 first and divide it by 64. So there's our pattern. If we multiply by negative 0.25, that's what's called the common ratio. You can use the letter R to abbreviate that. Now we need to come up with the next couple numbers, okay? So what I'm going to do is I'm going to start off by putting my first number in the sequence into the calculator. Now I'm going to multiply by the common ratio. Now I should start to see my numbers appear from my sequence. Next three are going to be 0.25, negative 0.0625, and that. I forget what that were, 0.25, negative 0.0625, you can convert these to fractions too. I'll show you that. If you got a fraction of decimal key, which I think I do here. So I can convert those to fractions too if I'd like to. Okay, let's go ahead and try that same concept for these. All right, everybody, go to it. All right, for number 4, here's my first two numbers, right? 3 divided by 1 is 3. So the next three numbers you would put in your calculator to get those answers. So I'm not going to write them down. I'm just going to leave them on my calculator. So I'm going to put a 1 in my sequence first. I'm going to multiply it by 3. There's the 3. There's a 927. Okay, here comes the next three. 81, 243, and 729. That's the answers number 4. Right there. Let's go over to number 5. So what I'm going to do is I'm going to take the first two numbers, I'm going to divide them in reverse order. I'm going to get my common ratio of 0.2. Okay, so I'm going to write that down. The common ratio is 0.2. And now what I'm going to do, I'm going to generate my sequence. So put my first number in, I multiply by 0.2. Now we'll see the first couple numbers of the sequence appear. And here comes the next three. 4, 0.8, and 0.16. Let's move on to the next problem. Okay, number 8. Or I'm sorry, number 6. Divide these first two numbers in reverse order. So it'd be negative 40 divided by 80. All right, so my common ratio is negative 0.5. Now I just need to come up with my numbers from the sequence. So put your first term into the sequence and multiply by your common ratio. Now you should double check that you get your numbers from your sequence. There they are. Here comes the next three. 5, negative 2.5, and 1.25. You could write those as fractions if you want to, but you don't need to. Finally, number 7. Take your first numbers, 4 divided by negative 2. Okay, that's negative 2. That's your common ratio. All right? So what you're going to do is you're going to record that. Common ratio is negative 2. Use that with the calculator to come up with all the terms of the sequence. So start with negative 2 and multiply that by the common ratio. Let's see if we get the numbers in the sequence. There's 4, there's negative 8, 16. All right, here we go. Next three. Negative 32, 64, and negative 128. And there is our lesson.